All right, we're going to take a look at 9-4. This is going to be talking about a game where it says red or black. In a simple card game, the dealer shuffles cards and then the player randomly selects a card and has to predict if it will be red or black. If you don't really know much about decks of cards, you don't need to worry. The biggest thing is half the deck is red and half of it is black. So it's exactly 50-50, and they keep putting the cards back every time. So this is sampling with replacement. So essentially every time it's a 50-50 chance. Says the player then returns the card to the deck, and this process is repeated until somebody's done it 20 times. Lindsay claims to be better than Luke at this game. Lindsay plays the game and gets 14 correct out of 20. And then Luke plays the game and gets 10 correct out of 20. Luke believes they are both equally skilled and that this result happened purely by chance. So, does this result provide convincing evidence that Lindsay is better than Luke at this game? It says identify the statistic and the parameter. So, in here, the statistic, we're going to look at two different groups. So, we're looking at Lindsay's wins versus Luke's wins. So, um, I'm going to do P, the statistics going to be P hat 1. So, I'm going to call it P hat Lindsay is P hat 1 minus P hat Luke. So in this case, that's going to be 14 out of 20 minus 10 out of 20. Or if I do it as decimals, this is 0.770 minus 0.5. So this difference would actually be 0.20. I'll do that in green. So this is really the difference, the proportion, sample proportion difference. We're doing Lindsay minus Luke. The parameter is the truth. So it's just going to be P Lindsay minus P Luke, which we don't know what it is. I could say that that's really the true mean difference between them. If I wanted to make a variable P diff. So it says there's two possible explanations for why Lindsay did better. So Luke says they're exactly the same. So really what he's saying is, P Lindsay is equal to P Luke, and oops. And basically what he's saying is it just happened by random chance that she beat him this time. It's not like there's any skill involved. Another way we can write this is if I use some algebra and I would just subtract P Luke from both sides. So what I do to one side, I do to the other. And if I do it that way, then I could also write it like P Lindsay minus P Luke equals 0. And this is just a more convenient way to compare it to a number. It means the same thing as this, but this is typically how we like to deal with it when we're writing stuff, because if I want to do normal curves and things, it's easier to compare it to a number. Lindsay has a different claim. She thinks she's actually better. So we're going to say that she is greater than Luke. But again, if I wanted to, I could subtract P Luke from both sides. And if I do that, I could also write that as P Lindsay minus P Luke is greater than 0. Just be another way of writing the same thing. This is not incorrect over here. This is not incorrect. It's just easier to deal with it when it's compared to a number like 0. So to test Luke's claim, we're going to assume number 1, they're both equally likely skilled, and find the probability that these results happen purely by chance. So it says play a game with a partner. Obviously, we don't have school today, so we're not going to be able to do that. I'm going to skip down to the teacher notes to just look at what they kind of did. It says repeat the process again for a second game to get another dot. So what you guys would be doing is finding your dots. The first one they did, they got 0.20, so their first dot would be right here, and we'd compare to that, but then I would have you guys make a bunch of other dots. So let's just scroll and just look at the sampling distribution that they got. So here's a sampling distribution for a class. So they did it a bunch of times, put a bunch of dots. So we're wondering, you know, what they got, their difference was 0.20. We're saying how many times did they get something like this, or even crazier, or like bigger? That happened 5 total times. Out of how many dots they did? Well, this class did it 30 times. So if you do 5 divided by 30, that's 0.17. So this would be a simulated p-value instead of doing it with a normal curve, which we could do and we will. This is just to give us the idea. So we're like, how likely is it that you would get something with that big of a difference if there really was no difference at all? And it says about 17%, so it's not that unlikely. So what does each dot represent? Well, it represents 2 random samples of 20 cards, and the difference in proportion of direct guesses for those samples. And we're doing it where it's Lindsay minus Luke. So Lindsay goes first, then Luke. Number 6, assuming that Lindsay and Luke were simply guessing, what's the probability of getting a difference um, of 20 or greater? Well, based on the dot plot, from what we saw, we got 5 out of 30. That's going to be our p-value, and they label it there in red. And then just to interpret it, we say, assuming that the null is true, that's really the same, there's a 17% chance that we get a sample that would be 0.20 or greater just by chance. So down here it says, based on the answer to 6, does the observed result give convincing evidence for Lindsay's claim? Well, I'd say no. They could actually be skilled because it's very likely if they are both exactly the same that you would get something that crazy. So this is us kind of doing our conclusion because 0.17 is greater than an alpha value of 0.05. We failed to reject the null, and we do not have convincing evidence that Lindsay is better than Luke. Just probably luck of the draw on that time. So in here, we have the quick notes here, and it says hypotheses. P1 minus P2 is the true difference of proportions in context. Your null is going to be that they're equal to 0, or it's the same as saying they're equal to each other, but it's easier to deal with it compared to a number. And then you could have a less than, you could have a greater than, or a two-sided test with that not equals. And then these are up online. Full conclusion for a significance test. It's going to be exactly what we did for one population. This is a 2-sample one. But it says, assuming HO is true, there is a blank probability of getting a sample difference of that or more extreme purely by chance. And then we talk about if our p-value is low, lower than alpha, then we reject. But if it's greater, we fail to reject. We don't have convincing evidence then. So we kind of did that in purple and red, depending on what happens when you guys conduct the test. So there's a check your understanding. Yes, you can go look at all the notes. I was going to go through here, kind of have you take a look. So in this one, it says, according to a recent Gallup poll, people who are college graduates are more likely to report they are satisfied with the way things are going with their personal life, and that people that are not college graduates, of the 354 graduates surveyed, or than people that are not college graduates, sorry. Of the 354 college that are surveyed, 311 report being satisfied. For the 384 that were not college graduates, 301 report being satisfied. So it says, is there convincing statistical evidence of a difference in the proportion that are satisfied with their personal lives for all college graduates and all that are not college graduates? So state the hypotheses for performing a significance test. All right, well, you got to write HO, oops, black here, HO and HA. I'm going to use P1 and P2. So I'm going to say P1 minus P2 is equal to 0. And I want to see if we want to, which way we want to go. So it says, is there convincing evidence of a difference? So when they say difference, I don't care if it's bigger or smaller. I just want to know if they're different. So I'm going to write, this is a two-sided test. So P1 minus P2 is not equal to 0. Then I also need to say, well, what is P1? Well, P1 is the true proportion of satisfied college graduates. And P2 would be the true proportion of satisfied non-college, non-grads. And then I should probably put down my statistic, which would be P hat 1 minus P hat 2, which would be 311 out of 354 minus 301 out of 384. And then I'd have to get a calculator out to figure out what that is. So I'm going to grab a calculator and do that here for a second. And actually, I'm going to cheat and just look here and say, oh, this one's 0.88 and this one's 0.78. So if I subtract them, I should get 0.10. So I'm going to go up here. So if we did this, it's 0.88, 0.78, or sorry, 0.88 minus is 0.10 is what I meant to say. So 0.10. All right, so this is 0.10 for the difference. So do the results have to provide some evidence for HA? Well, yeah, a little bit. I mean, our sample, at least it's not saying they're equal. I mean, if we got this minus this and it equaled 0, I'd be like, ooh, looks like it actually matches what the null is, but because there's some difference, it gives some evidence, but we don't know if it's convincing yet. But it gives some evidence. So the p-value is 0.004. They calculated it for us. Later I can show you how to do that, but to interpret it, what does it really mean? Well, it means um, the chances we would get a sample difference of 0.10 or more, assuming there is no difference in the population, purely by chance is 0.004. So this is 0.4%. The chances of being able to obtain something like that is like next to nothing. So it says at the 5% level, what conclusion can be made? Well, because our p-value of 0.004 is less than alpha 0.05, we reject the null. So we have convincing evidence to accept the alternative, put alt, that there is a difference in, I guess, life satisfaction between college and non-college grads. Now, this maybe there's a difference, but it doesn't explain what that difference is, and it doesn't explain what's causing it. We just have shown that we got some pretty good evidence to show that it actually is. I know I kind of just scrapped through that with my stuff here. I was trying to walk you through. Um, and here's the same thing that you guys have in kind of a cleaner format. I hope that this helps. I want you guys to try the 9.4 homework. Remember, all of this is up on the web as far as the notes. You can look at this whole thing. I put it in there. And have a great snow day. Shazam! I'm going to be watching Disney on Ice on YouTube for the rest of the day with Ruby, so things could be worse. All right, have a good day.